Alrighty, hello again. So third of 3 videos for the third lab this week. And we've talked about how to read and display images in MATLAB. We've talked about some different things we can do, right? We've talked about color channels, kind of the layering and getting data of each layer, corresponding to like red, green, and blue data for each pixel. We've learned how to introduce filters to our images, right? We learned how to grayscale an image. We learned how to apply like a sepia filter. We learned how to assign every pixel to just one color, or how to delete one color from every pixel in the image. All right, so those are a few of the things we've started with. And to wrap it up, there's a few more things we can do that are still very similar in nature to filters. And this is color transformations. Oops. Okay, so let's look at color transformations. To do this, let's first look at permutation of colors. Okay, so we can take all the colors and just kind of permute them, right? Each pixel has a certain number of like red in it, green in it, and blue, right? And we can just permute these numbers, right? It's say like, well, there's this much red and this much green and this much blue. Well, let's flip all those around, right? So that like what used to be like red, however much red was in the pixel, now there's green in it, and then et cetera, et cetera. So let's look at the permutation of colors. Okay, and so again, here we can just use these this double for loop that we've been using as like a template kind of, right? But really what we need to do is just define the filter matrix, or like in this case, maybe you'd call it like the color transformation matrix, right? So let's call this one the permute matrix. And so let's kind of go back over what's going on here, right? Just so we're comfortable. So what this is doing, well, here's something before I'm way ahead of myself here. Let's define how we permute colors, right? So we want to switch red, green, and blue. And so how you do that is you take a 3x3 matrix with zeros in every entry except the off diagonal, the anti-diagonal, and you put ones, right? So what is this doing? Essentially, what I'm doing right now is I'm permuting the colors red and blue, right? Because if you notice, green has not changed, but I'm permuting red and blue here. So 1, 0, 0. And now that I have this matrix, let's remind ourselves what's going on here. So for I, 1 through m, so for each like pixel in a given row, and then for each j, 1 through n, so for each pixel in a row, you go through the entire column, and then you move to the next pixel. You go through that entire column, et cetera, et cetera. This goes all the way across the image. We're excuse me, we're changing the pixel color with the reshape command, right? And we're extracting all this data from all these pixels, and we're just assigning it to a 3x1 matrix with red, green, and blue attributes. And then how we manipulate this is we define our new image, what we want our image to look like after it's filtered. So this one we'll call, like, say, mjpeg permute, okay? And so what you do then is you use the uint8 command, okay? And this time we're using the permute matrix. I had a couple snags in the last video with not getting my definitions in alignment. So let's make sure we are in alignment here. And we're taking this permutation matrix and we're multiplying it by this pixel color that has kind of reshaped this matrix just into red, green, and blue components. Right, and now we want to show this image with permuted colors. So assuming I didn't make a mistake like I did last time, looks like we're good to run. So I'll let all of these load here again. Thank you for your patience in advance with my slow computer. I'm actually intrigued because I've indicated that I don't want this output with a semicolon, but here we are. So that I just want like the most recent figure to be displayed. So this was the one that we deleted green, right? We kept all red and blue in every pixel, and we're getting some combination of red and blue, which turns out purple. And here we go. This is our permutation, right? So it kept green the same, and it just kind of shuffled like red and blue, and this is our image. Cool. So now, let me close out my 50 million tabs. Oh, so here we don't need to see this in the command window, right? And so this was how you permute colors. You basically just kind of permute the matrix, right? You change the matrix to indicate what you're wanting to flip visually, okay? So now that was for permutation of colors. We can saturate, right? This is also something that is probably considered a filter, right? Where there's like a saturated image, and there's different combinations of saturation you can do, right? You can saturate the blues, you can saturate the greens, you can saturate the purples by taking a combination of red and blue saturation, right? So let's see how to do this. So let's define a saturate matrix. Saturate matrix. Okay. And let's say we want like 3 times the saturation of red, 0.5 times the saturation of green, and let's leave blue alone, right? So, whoops. So here is our saturation. Saturate. Cannot spell. So here's our saturate matrix, right? And now we use our code, our for loop here, and we be lazy and we copy paste. So now this is saturate. Make sure I spelled it right. Yes. And I want my image to be saturated, right? So this is the image that we're saturating. And let's view it, right? Because again, what this is doing is it's taking this filter or color transformation matrix, and it's applying it to the extracted information we have about the original image, right? And so what these multiplications, like these products do here, like in this matrix multiplication, multiplying this number by 3 will saturate this the red in this image by a factor of 3. And the 0.5 here will back off the saturation of the image, of the green in the image, right? And then we decided to leave blue unchanged. So let's run this. And we can wait here again while my computer takes its sweet time. So there was our permuted image, and then hopefully coming up we'll have our saturated image. There we go. Yeah, right. So here you can see 3 times the amount of red really saturates it with red. And I extracted, I kind of backed off by a factor of 1/2 the green, and I left the blue alone. So this is what you get with an image that's saturated mostly with red, right? And so these kinds of like permutations and saturations, not so much saturations, but the permutations, the permutations are kind of a subset of a larger group of filters here. And I'm looking in the lab now. Okay. And so the permute matrix is just one example of a huge combination of hue rotation filters that you can produce. And so here in the lab, you can see how these matrices are defined, okay? And you basically what you can do is copy paste this into your script, and then you can play around with different values of theta. It's called hue rotation because the matrices are defined using these angles, right? And then so you just like, you look at how the colors change, like the hue changes as you pick different angles. And you should really play around with these different kinds of hue rotations and see what you can come up with. You can come up with some really, really interesting things. So anyway, so that's what we have for permutations and saturations. And there's one last thing that I would like to talk about. And then after that, you'll be well equipped to handle everything the lab throws at you. So lastly, one thing we can do is we can invert colors of an image, right? So I'm sure you guys have all seen like inverted color images, right? Where it can look kind of creepy or strange or whatever. So let's see how we can do that with MATLAB. So basically all we do, this is pretty simple. You just take your image, and we'll call this new one image JPEG invert. Okay, I think that's how the lab defines it. And basically, remember all of these pixels, how they're assigned colors is they take on values between 0 and 225, right? So if something's maxed out in red, it has a red value of 225. If it has some green, but not that much, it might have a green value of like 150 or something, right? And so for red, green, and blue, there's these numbers between 0 and 255. 255 being like the maxed, like all red, right? And to invert it, all you do is you take 255 minus our original image, right? And so then figure image show, let's look at our inverted JPEG. Okay. Oh, there we go. Sorry about that. Small typo. Looks like everything's running fine now. Can look back at all our previous filters here as we wrap up the lab. Okay, so the next one should be our saturation. And here's our inverted image, right? And so you can see that really just takes the inverse of whatever your color was, right? So whatever like values you've assigned to that pixel, well, to get visually to see an inverted color is you just take the difference from 255 and that gives you the opposite, right? So if there was like originally only 5 of a given color in a certain pixel, when you invert it, then there's 200 of that in that pixel, right? So we really do get inverted colors here, and it makes sense like with all the writing that was up here, right? Like one of the visually one of the easiest things to see is white and black being inverted between each other, right? And all this writing was white in the original photo, and now it's all black because you know, to get something like when we got something gray, it was you average everything out, right? Just you just average everything out. To get white, you max every color out, and then to get black, you have no color at all, right? So so we can see that here, and so that's really that about wraps up all the figure or all the color manipulation we'll be doing with images here. And I really should have suppressed that. Here you can see how, just to wrap up here, you can see how much is stored in these matrices. Like there's a lot of data expressing an image as a matrix, right? Which may be motivation to remember your semicolons when you're going through this lab. So that's all for lab 3. Thank you all for listening, and I will see you guys next time.